Hey, welcome to this video on the Tableau Certified Data Analyst exam. We're going to be looking at creating basic charts, and there are a whole lot of charts under this section, but it's not going to take too long to cover them because they're all relatively simple to create. So here we're going to look at bar charts, we're going to look at line charts, we're going to look at pie charts, highlight tables, scatter plots, histograms, tree maps, bubbles, data tables, Gantt, and box plots, area charts, and dual axis, and finally combo charts. And so pro tip, if I'm going too quickly or too slowly, please adjust the speed of the video as needed. Now here's some of the documentation. So this page has links to the steps to build all of the basic chart types, and I'll be placing a link to this along with the video. Now I'm going to switch into a demo so I can show you how to create these particular chart types. And so we're going to start out with bar chart. I have the Superstore data open here, and I'm going to double click sales, and then boom, I have a bar chart right off the bat. That's the default. And I can add more dimensions here. I should also mention that you can use this show me table to select the type of bar chart or type of chart in general. Of course, you need the right data in your view. So you need at least one measure to create a horizontal bar chart or a vertical bar chart, right? Right now I have the horizontal. I can just flip it with this to, right now I had the vertical. I can just flip it over to the horizontal like that, flip back and forth. I can add a dimension here to make it a stacked bar chart. So the stacked bar chart needs at least one dimension. And so I'm gonna just drag over ship mode like this. And now I get a stacked bar chart. I can also have it as a side-by-side bar chart. So this is the other next option. So we got the horizontal bar chart, vertical bar chart, stacked bars, and then side-by-side bars. So if I want side-by-side, I would just drag this over here, and that gives me the side-by-side. Or if I Control Z, the other way I could switch to it is by clicking this under the show me. Now I have the side-by-side bars. If I don't want these different colors, I can just drag that out there. The other thing to mention is you can make changes by dragging dimensions and measures into this marks card area. So if I want the bar size to vary, the thickness of the bar by some other dimension, I could drag that over to size. And then I'm going to see that the sizes vary based on how profitable this is. So the length of the bars is defined by the sum of profit, the sum of sales, but the width of the bars is defined by sum of profit because I've used the size option here. Now I can switch that over to color and then have sum of profit be defined by this color gradient, where the not profitable is like that kind of tannish color and the more profitable is the darkest blue. So by dragging over, I can change how the bar chart appears. I'm going to just drag over to tooltip, and so now the color doesn't vary, but now when I use my tooltip, I see sum of profit as well as sum of sales. So now the bar length is defined by sum of sales, same as before, but I've also added sum of profit to the tooltip. So those are different options with the bar chart. Now let's see about switching over to line. With a line chart, you need at least one date. And so you see that this option is grayed out for me right now. So I'm going to remove region and I'm going to add date to the view. And now it gives me a line chart right off the bat. There's two different ones. There's a discrete line chart, and so that's got the headers down here, or the continuous line chart. And so that has, instead of headers, it has an axis, right? That's the difference between dimensions and measures. When you're using a measure, you get an axis. And so that's what I have down here is I've got this axis. If I switch and make this discrete, it's going to change it over to switch it over to discrete like that. It's going to change it over to using headers, and so that gives me a different look. And so now I have a different line for each different ship class. If I remove ship mode from here, then I just get one line that's aggregated for the whole data set. So this is the total sales. I can also drill down into the quarter, into the month, into the week, and I can switch from discrete to continuous, so that I switch from headers to an axis. So that is line charts. Now let's take a look at pie charts. A lot of people don't really like pie charts because they It's difficult to really see the scale as easily as you can with a bar chart. But if I do this and then I switch it over to pie chart, now you see that each slice of the pie represents a different subcategory and the different sum of sales for that subcategory. And if I click on this and I want it bigger, I can do this. Up, now it'll get bigger. I can make the slices a little bigger or smaller like that. So that's the pie chart. I can click on a few of these and say keep only, and now I have a pie chart with just those specific subcategories that I've selected. I can also add tooltips or labels, so I can add labels like this so I can see the sum of sales actual value for each slice. So that's a little bit about pie charts. Now let's take a look at highlight tables. Maybe I'll just start a new tab here. I'm going to do sales, subcategory, product name, and now let's see. Can I do this? Maybe I'll do, instead of subcategory, I'll do category. It's getting too big. This is a table, but with the sort of distinction that the values have colors to also represent the magnitude of the measure, right? So we've got sum of sales and we see that the specific value, but we also see it colored. And this allows me to very quickly narrow down on the extreme values, right? So I can see that this is a very high value and then these numbers are down here. These are very low values and I can see that based on their color. Next up, let's take a look at scatter plots. I'm going to start a new worksheet here. And so for scatter plots, if you mouse over this, you see what's needed. Needs 2 to 4 measures and 0 or more dimensions. So let's add sales and profit. We've only got one dot here, so that's not very interesting. So I'm going to add subcategory. And so we can see how the total sales and total profit vary for each subcategory. And you see that in general, I'm going to just switch them. I'd like to have the sales on the x-axis and the profit on the y-axis. And so now you can see that generally they go up together, but it's not a sort of 100% correlated relationship. The dots are all the same size, right? So what I can do is I can use another measure to show how they vary by size. For example, I can put in quantity and make the dots vary by size depending on their quantities. Lower quantity of this ordered versus higher quantity of that ordered, right? So I can do that with the size of the dots. I can also make the color of the dots vary, right? So I can do drag over discount and use that to make the colors. Oops, I just lost my subcategory. I'm going to change subcategory to like a shape. So now I'll get a different shape for each subcategory. And now I'm going to drag over discount and make the color vary by discount. And so the darker ones are the ones with the biggest discount. So I guess this one has a very high total discount value, or I could do average discount. Maybe that would make more sense. And just switch it over to the average discount. And so the darker ones are the ones with a higher average discount value. The lighter ones are the ones with the lower average discount value. And I have a different symbol for each subcategory. So I could say, okay, well, what subcategory is this over here? This is phones versus binders, right? And if you go on the right side, you can see phones and binders. Those two actually look pretty similar here, but that's a scatter plot using the size to represent the sum of quantity, the color to represent the average discount, the x-axis to represent sales, and the y-axis sum of sales, and the y-axis to represent sum of profit. And then each point on the scatter plot is representing a different subcategory. Now let's take a look at histograms. Histograms are useful for looking at the distribution of data. For a histogram, I only need, I believe, one measure to create a histogram. Where's this? Here's a histogram, so we just need one measure to create a histogram. So if I add sales, and then I click histogram, now I see the distribution of the values. This is looking at the individual row level and giving me how many values in the original data set fall into this range. When I create the histogram, it gives me a bin for sales. So I can adjust this. I can click edit and make the bin smaller. Right now the bins, the size of each bin is about 507. Each bar represents a range. So this is going to be values between 0 and 507. And so if I right click and I say view data, I can see that the values of sales in the original data should vary between 0 and 507. So you see that. And then in the next bin, view data, we see the values here vary between 508 and 1013. So if I want to change this, I can right click and say, let's make the bins just 100. And I guess there must be some extreme values, which is why I still see all this. So maybe I'll add a filter here and so now I'm just seeing the sort of normal range of values because the whole thing was kind of too small before. If I right click here, I'm going to see that the values are between 0 and 100. The top value is very close to 100, just under, and then the bottom value is very close to 0. Right? And so what this tells me is that I have 6,226 rows in my data set where the value of sales is in that range of 0 to 100. And then I have 1,189 rows in the data set where the value is between 100 and 200, 675 values where the value is between 200 and 300, 449 values in my data set where the value is between 300 and 400. I can click this and just show you this so you can see that yes, these values are between 300 and 400. And so this basically is a way to say, okay, well, what's the typical values and what's the range of values and are there extreme values, right? We see that actually there are some cases where the sum of sales is in between 3,000 and 3,100. And actually, if I remove this, there are even some higher values somewhere out here. Yeah, there's one value right here. So I can say view data and see that, yeah, I have this one extreme value here where the sum of the sales for this row was actually $22,683.48. So this is a sort of a super high value sale. This is what's called looking at the distribution of the data. So we see that most of the sales values are less than $100, but or many of them. We could change this to a percent actually. If I do quick table calculation percent of total, I can see that actually 62%, a little over 62% of the values are in the $0 to $100 range. So most of the orders or most of the individual row level transactions are relatively small. They're in under $100. But then there is 10.9% that's between $1 and $200. Next, let's take a look at tree maps. So for tree maps, we need one or more dimensions and one or two measures. We're going to add ship mode and subcategory and segment maybe. We'll add a few different things and then we'll add sales and profit. And so now let's see what happens when we switch it over to a tree map. So here we see that sum of sales is the color is represented by sum of sales. The size is represented by sum of profit. So the bigger squares have more profit. Each combination of these dimensions is represented by a different rectangle. So this rectangle represents the values for consumer, standard class shipping mode, and binders. And we get a different square for each. And so the combination of the size and the color tell us the relative these two relative magnitudes, right? So can we find, for example, high sales that are from a relatively small profit, right? We could see that the color should be very dark, right? Like this has a pretty dark color, but it's a relatively small profit. So this is like, we're doing a lot of sales in the consumer of machines, but we're actually not making very much profit. So that's a dark one, but it's small. Now, do we see any large ones so that are light colored? So we're not making a lot of sales, but we have relatively high profit. Well, like this one, for example, is pretty light, but it's so it's relatively low sales, but it's relatively high profit because it's a pretty big sized rectangle, right? And so the size of the rectangle, or the size measure, is being used to visualize profit. So the larger the rectangle, the more profitable. So this is pretty profitable, but has relatively low sales, whereas this is both profitable and has high sales. This one in the top left, right? It's it's more profitable than this one, so it's a bigger rectangle, but it also has higher sales, so it's a darker color. And so that's the tree map. Now let's take a look at bubbles. So here we see the circle views, which I think is what we're calling bubbles, right? They need one or more dimensions and one or more measures. So we can add this, and then we switch it over to bubbles and we get a different size bubble for each product, right? And we can add like a category here as well, like this, And so we see these different dots, and this is a way to kind of look at the individual elements here. Okay, so I see, wow, this is a very high sales item in the technology group, right? So this lets me very quickly see the distribution. Like I see that furniture, well, this is my top one, is this task chair for big and tall. Then in office supplies, we've got this binding machine, right? And then in the technology, we've got this advanced copier. So those are our most expensive items in each category. And this kind of lets us quickly see the outliers, right? And so we could do the same thing for sum of profit, just put it over here and see, oh, is it the same? Yes. Looks like some of the same things are popping to the top in terms of the profitability. But then we also have some negative profit items. So that's bubbles. Now let's take a look at data tables. Data tables are one of the most common ones, right? Which is just text table, where you just basically want to look at what the actual values are and for the given dimensions. And this is, one of the most common types, especially if the amount of data you have to look at is relatively small. If I just need to look at 3 numbers, I think it's easier to just see what the actual numbers are than to have a bar chart, right? I can just say, okay, I want to know, what were my sales for technology, office supplies, and furniture, right? And these are the 3 numbers, so it's pretty quick to look and see what these are. Whereas if I'm trying to deal with hundreds of numbers, like how this varies, over time, right, by month, it gets to be too much to look at it as a text table. And so it's actually easier to look at it as a chart, right? If you see all these values, this is getting pretty overwhelming to look at. But if I switch it to a line chart, you can see, oh, wow, these were some extreme months. And I see that overall these things are varying. It looks like a lot of the time the red is the top, right? The technology is the top, but and there were some spikes over here, right? And then blue seems to always be consistently lower, and orange is kind of number 2, right? So I can kind of see that, see how it varies by month, see that there are some spikes. Yeah, it looks like technology had a spike here, right? And kind of pick it out quickly. So that's easier to do compared to this. But if you're only looking at a single value, right? Like 1 year or something like that, or maybe 4 years like this, it's probably quicker to just have a text table. Next, let's take a look at Gantt charts. Going to start a new worksheet here. And if you look at the Gantt chart under the Show Me menu, you can see that it has these kind of horizontal bars, which are meant to display periods of time from the time that a task starts to when it finishes. I'm going to create a new calculated field called days to ship, where I do date diff, and that's going to go from the day from order date to end date, or ship date rather. And so that's my days to ship. Once I have that, I'm going to put order date here, go down to the day here, the exact day. I'm also going to put this days to ship value here as the size. And so and then I'm going to put order ID in here, order ID, or maybe row ID. I'll do row ID and add all members. And so now we get this view, this Gantt view, with each particular transaction and when it shipped and how long it took to ship, right? So for example, this one says it was on June 9th and it took 5 days to ship. Now I'm going to maybe just look at the ones that took a long time to ship. So I'm going to do all values and I'm going to do at least 5. So these are the longer length ones, and maybe I'll just look at one particular period. So order date, range of dates, let's do 1/1 to just the month of just about a month in 2014, maybe a little longer, right? So now I've got all of these different orders, and I could add the order ID. Maybe the order ID is the same for a given. Yeah, maybe we could just do it this way. Do the max days for the order. Max. So this gives me the different time periods that these different orders were shipping for, right? And so this is basically saying it started, the order was placed on the 20th, and then it took 5 days for it to ship. And so this is a longer one because you see the bar is longer. This is a way to visualize when things are happening in the organization, right? The order was put in on a certain date, and then it took this long to actually ship it. And so it's basically tracking on this axis the time, it's the period that we're preparing the shipment to be sent out the door. This is a way that basically you can track tasks across time. If you think of these as projects, for example, if these were projects, it would say, okay, this is the start time of the project and this is the length of the project. And so then we can visualize what projects were happening at a particular point in time, which projects were active. So that is the Gantt chart. Next, let's take a look at box plots. Maybe should have covered this along with histograms because it's a very similar concept. It's a way to visualize distributions. It's a little bit of a different view, but it's similar in that it's visualizing distribution. Right now I have the sum of sales. I'm going to do like this. Oops, I'm doing ship mode here. Do ship mode like this. And you see that there's only a single point. And that's because for this view, I need to disaggregate the data so that I can look at the individual values. And so I need to go up to analysis and remove this aggregate measures. And now I do see box plots. The thing is, there are some extreme values, so it kind of scrunches up the middle of the data. But the point here is this area, I think I'm going to add a filter to remove some of these extreme values here so we can look at just the values, like let's say at most 5,000, so that it's not so scrunched. And so this gives me the middle of the data, right? The middle of this value, if I mouse over this, I see, okay, here's the median, here's the lower hinge and the upper hinge. And so that's basically saying the lower hinge would be the bottom 25% of the data approximately, and the upper hinge would be the upper 75%, right? And then we also have the whiskers, which are sort of the extreme. So if I right click here, I should be able to set some settings on this. So this tells me that the inner quartile range is the middle 50% of the data, leaving out the highest 25% and the lowest 25%. The middle of the data, the middle 50% of the data is represented by this line and this line, right? And then this line between the light gray and the dark gray, that is, and I think I'm going to make this even a little bit more extreme, put it up to like 1500 so I can show you better what this looks like. Yeah, now I can see it better. So the dark part, this is the between the 25th percentile and the 50th percentile, and then the lighter part is the 50th to the 75th percentile. And then this whisker is the 1.5 times the interquartile range, right? So this is basically a wider band. And then these are obviously more extreme values outside of that. So this gives me a sense of where the sort of middle 50% of the data is, and then also where the more extreme values are. That's the purpose of these box plots. And so here that you see they're approximately similar. I think it'll be more interesting if I put the category here. If I do category, you'll see a little bit more differentiation, I think, of the different product types. So you see that with technology and furniture, the distributions are relatively similar, whereas with office supplies, they tend to be like lower value. Although the extremes are sort of closer in here, but that's again because we have the filter set, right? So if I do this, then I can see the extreme value. So it looks like, you can see that the middle 50% of the data for furniture and technology is pretty close, but the really, really high value sales tend to come more in technology. And so that is a box plot, which is a way to visualize the distribution of the data. Next up, let's take a look at area charts. So these are the two types of area charts. So they're similar to line charts. I'll just start off here. We need a date field. So we'll do order date and sales, and maybe let's see, product category. Got our product category, and now we're going to do an area chart. Instead of showing lines, we show the areas. The difference here is this gives me the total sales, and so I can see that the overall sales is now above 700K, right? So it's additive. It's like kind of like a stacked bar chart where I'm stacking these values up, but it's also showing change over time with these different lines. But if you see that if I switch it to a bar chart and do it this way, and make it stacked, it's a little bit similar. But now I'm going to switch it back to the line chart. And so here you see that these lines are overlapping rather than additive. They don't add up. Whereas with an area chart, the lines are adding up to the total. And so again, we have an option to do continuous or discrete. So this is the discrete with headers. This is the discrete with headers here. And then this is the continuous of the area chart. That's the area options. It's another way to visualize, similar to the line chart, but it does kind of stack up to the total values rather than having the lines overlapping the way they would if we did this, right? So we have this option with a line and this option with the area. These, you notice here, are not adding up. They're just each one by itself, whereas this one, when we do this one, these values, the technology plus the office supplies plus the furniture, give us a total of almost 750,000. Next, let's take a look at dual axis. This is handy if you want to handle two different measures. For example, here we have, I'm going to set up this region. So I have, want a bar chart here. So here I have these two different bar charts with different axes, but I want to overlap them. So if I click on this and say dual axis, now I see them together. The orange color is showing me the sales based on this axis, and the blue color is showing me the profit based on this axis, right? So blue goes with this axis, and sales goes with this axis. The thing is, they're not synchronized. So 60K over here goes with 400K over here. So if I want to synchronize them, I can do this, synchronize axis. The profit values are all lower relative to the sales values. Sales tends to be much higher. Only a portion of your sales is going to be seen as profit, and so the profit numbers are lower. You can do, this with line charts as well. Other types of graphs, like if I had a date instead. So if I put ship date here instead, we now have a dual axis looking at ship date over time. So that's a dual axis chart. The other thing we can do is we can actually change the way that these are visualized. So here we have a line and another line, but we can do a combination of different visualizations. So instead of doing a line and another line, we can change it to, for example, a line and a bar, right? So now we have these bars and also these lines, and that's a combination chart. That's the last chart type we're going to talk about. So that's where we're using two different graph types together for a sort of combination chart, right? So we can have multiple different ways of visualizing these things. So different options here. That's what I have for creating basic chart types in Tableau. Now I want to just close it out with a very relevant quote from Edward Tufte. He says, "Graphical excellence is that which gives to the viewer the greatest number of ideas in the shortest time with the least ink in the smallest space."